Introduction. Welcome to this audiobook where we delve into critical concepts in modern cloud infrastructure and security, namely Site Reliability Engineering, SRE, Auth0, OAuth, and JSON Web Tokens, JWT. These concepts play a significant role in building, securing, and scaling applications. Throughout this book, we will explore how they are applied in real-world systems and why they are crucial to the functioning of modern web applications. Chapter 1. Site Reliability Engineering, SRE. Site Reliability Engineering, or SRE, is an evolving field that brings together the best of software engineering and operations to ensure that systems are reliable, scalable, and maintainable. The core goal of SRE is to ensure that software systems run smoothly, even under high traffic or failures, while also automating repetitive tasks to minimize human intervention. Google pioneered this practice to ensure its infrastructure is both scalable and resilient. SRE emphasizes the use of service-level objectives, SLOs, which help set clear expectations for system performance. For example, a service might be expected to be available 99.9% of the time, which translates to only 8.77 hours of downtime per year. This provides a quantifiable way of measuring reliability. Additionally, SRE introduces the concept of an error budget, which acts as a balance between the speed of developing new features and maintaining reliability. If the system exceeds the acceptable error budget, development efforts should shift towards fixing reliability issues. Another key practice in SRE is automation, which aims to reduce manual tasks. By automating monitoring, incident response, and deployments, SRE teams are able to focus on addressing critical issues and improving system stability. Chapter 2. Auth0. Moving on to Auth0, a leading identity management platform. Auth0 is an authentication and authorization service that helps developers implement secure login systems in their applications without having to build and maintain complex authentication flows from scratch. It provides everything from user registration to login, as well as advanced features like multi-factor authentication, MFA, and passwordless login. One of the primary benefits of Auth0 is that it supports a wide variety of authentication methods. Users can sign in using social login providers such as Google or Facebook, enterprise logins via Active Directory or LabDAP, or even using custom authentication methods. This flexibility allows developers to integrate various identity providers, ensuring that the user authentication experience is seamless across different platforms and devices. Auth0 also helps manage authorization, the process of determining whether a user has permission to access certain resources. After a user authenticates, Auth0 provides tools for role-based access control, RBAC, and fine-grained authorization to ensure that users can only access the resources they are permitted to use. Chapter 3. OAuth, Authorization Framework. Let's dive into OAuth, which is an open standard for authorization commonly used to give third-party services limited access to a user's resources without exposing their credentials. OAuth is designed to provide a secure method for delegating authorization across various applications without sharing passwords. OAuth allows one service to request permission from a user to access their data from another service on their behalf. At the heart of OAuth is the concept of tokens. These tokens represent the permissions granted by the user to the third-party service. Rather than requiring users to provide their username and password to each service, OAuth allows them to authenticate once and authorize access to their data through the token. OAuth is often used alongside JWT for securely transmitting authorization information between services. The OAuth flow typically involves the user being redirected to an authorization server, where they log in and grant permission to the client app to access their data. Once the user approves, an access token is issued to the client, which can then use it to access the resource server on behalf of the user. Chapter 4. JSON Web Tokens, JWT. Next, we explore JWT, which is an open standard used to securely transmit information between two parties as a JSON object. A JWT can be signed, meaning that the recipient can verify that the sender is who it says it is, and the message wasn't tampered with along the way. The main advantage of using JWTs is that they allow you to handle authentication and authorization in a stateless manner, meaning there is no need for the server to store session information. A JWT is composed of three parts: the header, the payload, and the signature. The header typically contains the type of token, JWT, and the signing algorithm used, for example, HMAC, RSA. The payload contains the claims, which are the statements about an entity, typically the user, and additional metadata. These claims can include information such as the user's ID, roles, and permissions. The signature is used to verify that the token has not been altered. In an authentication context, a user may log in and the server issues a JWT, which the client then stores, typically in local storage or cookies. The client includes the JWT in the authorization header of subsequent requests to access protected resources. Since the token contains all the necessary claims, the server can authenticate and authorize the user without needing to maintain session state. While JWTs are a popular choice for stateless authentication, they come with certain disadvantages, including token size, lack of token revocation, potential security vulnerabilities if misconfigured, complexity in managing claims, and issues with session management. When using JWTs, it is essential to carefully design your system, manage token expiration and revocation effectively, and implement robust security measures to mitigate these risks. Chapter 5: Authentication versus Authorization. To fully understand how OAuth and JWT fit into modern application security, it's essential to differentiate between authentication and authorization, two closely related but distinct concepts. Authentication is the process of verifying the identity of a user. It answers the question, "Who are you?" This is typically done via login credentials, for example, a username and password, or through identity providers like Google or Facebook. Auth0 is a popular service that simplifies authentication by managing the entire authentication flow. On the other hand, authorization determines what a user can do once they are authenticated. It answers the question, what are you allowed to do? For instance, after logging in, a user might be authorized to view their profile but not to delete others' data. OAuth and JWT are often used together in authorization processes. OAuth ensures that a user has granted permission for a third-party app to access their data, and JWT ensures that the client can securely carry this permission data across requests. In modern systems, authentication and authorization are often decoupled. A user may authenticate once, for example, via Auth0, and then be issued a token, such as a JWT, which is used in subsequent requests to authorize the user's access to different parts of the system. This separation of concerns makes systems more secure and easier to scale. Chapter 6: How SRE, Auth0, OAuth, and JWT work together. To wrap up, let's see how all these components, SRE, Auth0, OAuth, and JWT, work together to create a reliable, secure, and scalable application. SRE ensures that the infrastructure on which the application runs is highly available, scalable, and resilient. The SRE team ensures the service remains reliable, meeting predefined SLOs and using error budgets to manage downtime. Auth0 simplifies the authentication and authorization process by managing user identity and providing secure authentication. OAuth plays a crucial role in enabling delegated authorization, allowing users to safely give third-party apps access to their resources without sharing credentials. JWTs then carry the authorization information securely, ensuring that each request made by a client is properly authenticated and authorized. By combining these tools and practices, developers can focus on building robust applications without needing to worry about reinventing complex authentication, authorization, and reliability mechanisms. Single sign-on, SSO, is an authentication process that allows a user to access multiple applications or services with a single set of login credentials. This means that after a user logs in once, they don't need to log in again to access other connected applications or systems during that session. SSO enhances the user experience by simplifying the login process and reducing the number of times users need to enter their credentials. How SSO works? SSO works by using a centralized authentication system, usually provided by a third-party identity provider, such as Auth0, Okta, or Active Directory. When a user logs into an application for the first time, the identity provider authenticates the user's credentials. After successful authentication, the provider generates a token or session information that the user can use to access other applications without needing to log in again. The typical flow for an SSO process looks like this. User requests access. The user tries to access an application, for example, an internal app or a third-party service. Redirection to identity provider. The application redirects the user to the identity provider, IDP, for authentication if they are not already logged in. Authentication. The user enters their credentials, and the IDP verifies them. Token generation. Once the user is authenticated, the IDP generates an authentication token, like a JWT or a session. Access granted. The token is sent back to the application, granting access. The user is now authenticated for other applications connected to the same IDP. Benefits of SSO. Convenience. Users only need to remember one set of credentials, which reduces login fatigue. Improved security. Centralizing authentication in one place makes it easier to enforce security policies, such as multi-factor authentication, MFA, or complex password rules. Reduced password fatigue. Users no longer need to create and remember multiple passwords for different applications, which reduces the chances of weak or reused passwords. Easier administration. For IT administrators, SSO simplifies user management, allowing them to control access to multiple applications from a single point. SSO protocols. Several protocols are commonly used to implement SSO. SAML, Security Assertion Markup Language. SAML is an XML-based protocol often used in enterprise environments. It allows secure sharing of authentication and authorization data between identity providers and service providers. OAuth. OAuth is an authorization protocol that can also be used for authentication, especially in modern web applications. It allows users to grant applications access to their data without sharing credentials, often used in conjunction with OpenID Connect for SSO. OpenID Connect, OIDC. Built on top of OAuth 2.0, OpenID Connect is a protocol that provides both authentication and authorization. It's commonly used in cloud applications and mobile apps to implement SSO. Real-world example of SSO. Consider a company that uses Google Workspace, Slack, and Salesforce for its operations. Instead of requiring employees to log into each application separately, the company uses an SSO solution like Google Identity Platform. Employees log into their Google account once, and they can seamlessly access all these applications without needing to log in again. The authentication process is handled by Google, which issues tokens that are recognized by the other applications. In summary, Single Sign-On, SSO, simplifies and secures the login process by allowing users to authenticate once and gain access to multiple services. It improves security by centralizing authentication and makes managing access across systems easier for IT teams. SSO is essential for modern enterprise environments, especially as they scale and require access to multiple systems, both internal and external. Conclusion. In this audiobook, we explored SRE, Auth0, OAuth, and JWT, understanding their individual roles and how they come together to create secure, scalable, and reliable systems. As software development continues to evolve, these tools are essential for building applications that not only perform well but also provide a secure experience for users. By mastering these concepts, developers can ensure their applications meet the ever-growing demands of modern digital infrastructure.